Okay. Let's start then by talking about what robustness is. Before we say how to fix robustness, I think it would help if we all had a common understanding of what we mean. We're out of clicker. This is really annoying, isn't it? Oh dear. Oh well. Good job I'm not bold on top with the camera and everything. So what do you think robustness is? Anybody? Anyone got a definition of robustness?
Sort of not allowed to break. Like
not allowed to break.
Sort of a wee bit tolerant to, like, hard to break or something. I don't know.
Tolerant's good. I like tolerant. That's a good word. I wish I'd thought of that for my slides, I'll be honest. Anybody else? What does robustness mean to you? Does it mean anything?
I wouldn't say tolerant. I'd say it like deals with rubbish.
Deals with rubbish. Okay.
Doesn't have to accept it.
Doesn't have to accept it, but it handles it. Okay. I'm going to come back to that point. Anyone else? Okay.
Handles unexpected situations in a stable way.
Okay, yep. Handles unexpected situations. That's a very good point. Okay.
Something about having confidence as well in all the different tests that we can put it through.
Okay. Well, we're going to go straight into that one then. Right. How many of you have heard of happy path programming? Okay.
No.
Nope. All right. So happy path programming looks like this. You start off. Bear with me. Bear with me.
Yeah, okay.
Yeah. You start off with one algorithm or one functional method. It calls some others all the way through to the end of whatever operation, whatever HTTP request you're supporting. Okay? That's happy path programming. It just goes all the way through and everyone's happy, everything works. Now, the reason we call it happy path is because all it cares about is that if you give it the right input, you get the right output out. It doesn't care about anything else. It doesn't care about handling rubbish. It doesn't care about handling the unexpected at all. It's coded and it's tested, because happy path code can ship with 100% code coverage, it still falls flat on its face in production, because it's all focused around what's expected to happen rather than what will happen, and that's why it's known as the happy path, because it's like pretending that all these other things that go wrong don't exist. I wish it was true. It made life so much easier. But the problem is, the happy path programming, it's a world without robustness. The moment you introduce something that isn't an expected input, you've got problems. So what has this got to do with robustness? Well, first of all, I think it's important to deal with correctness. A lot of the testing techniques you'll see people talk about, a lot of the programming techniques you'll see people talk about are actually focused about correctness, not robustness. And correctness is about, if I give it the right input, I get the right output. Okay? And you'll see a lot of apps out there with 100% code coverage. All they're doing is doing correctness testing in their unit tests. They're giving it the inputs that are supposed to happen. And when you fix all those bugs, the happy path works and everybody's happy, at least in test. Put it on production, not so much. Okay. So, unfortunately, in the real world, you don't get the inputs you're expecting. You can't control those inputs. And so you've got to add robustness code to deal with all of that, because they do happen. I've never seen a system that worked without robustness added. Never seen one in 25 years. I mean, robustness was a lot harder in the old days before we had scoped languages. When I first started, memory was flat. Any piece of code could write to any piece of memory. There was no protections, there was no public-private protected or anything like that. And of course, code did all the time. So robustness there was a very different kettle of fish to where we are today. Our languages help us a lot. But robustness looks like this. How many of you have done UML? Unified Modeling Language. So I can't remember if robustness diagrams are part of the standard these days or if they're still an extension. I came across them in 2001. A very mad Dutchman who was very mad at me for not writing robust code. And he would spend hours on me with this. And he taught me this by drawing these type of diagrams. So blue's your happy path, And then the yellow, hopefully it's yellow, represents when things go wrong and the fact you've got to deal with it. And the thing with the happy path is robustness problems can happen anywhere along that path. So you've got to add a lot of extra code to deal with all the things that could go wrong. Which is why a lot of people don't do it, because most of us are struggling to hit a deadline just getting this bit done. Once you start adding all of this, and especially if you're dealing with project managers or customers who have no background in software engineering and don't understand the need for this, you spend as much time arguing about who's going to pay for this work as you do actually getting it done. Robustness code can easily add half to double your IT budget, your programming budget, depending on the system you're building. It can be very expensive, but tell you what, it's more expensive if you don't do it and you ship it first. Because if you ship it without robustness, that's what ends up happening. Your happy path gets blocked partway through, something goes wrong, and you've got a mess. But that mess isn't in a nice, sane test environment that you can scrap and rebuild. That test is in production, where you've got real customer data. If you're working in a regulated industry where you've not just got data protection, but you've also got to make sure records are preserved over time, you've got big, big problems. So coming back then to a definition of robustness. Robustness bugs, they stop code that should work, they stop it working. You've tested it, you've got your happy path working with the expected inputs, and then something else comes along outside of that, and those are your robustness bugs. They're not bugs in your algorithm, they're bugs in the way you protect those algorithms. It's an important differentiation. And you'll see a lot of people end up talking about correctness when they mean, well, we've talked about robustness, but they mean correctness because they're talking about finding algorithm bugs. And that's not what I'm talking about here. I'm talking about when your algorithm works and then someone throws a spanner in the works. That's what I'm talking about. Now, I'm from Yorkshire, and when I was a lad, we had a phrase, "There but for the grace of God go I." And we used to describe it to the kids who cycled down the middle of the road and didn't care about cars or anything and going, well, no one's going to hit me, I'll be perfectly fine, that sort of thing. Oblivious to the risks in the world. Risks don't exist. And if your code's not robust and made robust, that's what's going on. Your code only works because an accident hasn't happened. Now, anyone who's been on the receiving end of an accident knows it's normally not your fault. That's why it's an accident. It's one of these things, they just happen. So the 5 patterns, the 5 techniques I'm going to teach you and show you, the ones I use, turn the happy path into something that can cope with all these robustness issues. And I've been banging this drum already, but I'm going to do it one more time. Deal with it up front. This is the most important lesson I have learned. They talk about, rightly or wrongly, they talk about stages of a project, and any bug that gets from one stage to the next costs 10 times the amount to fix. Now, there's no actual source reference for that. There's no actual data behind that. We were taught that back in the 80s. They still teach it today. It certainly is more expensive to fix things in a later stage, a lot more expensive. Not just because all of a sudden you've got a mess to clean up, but the work you're supposed to be doing, which is supposed to be paying your wages if you're a commercial programmer, you're not doing that because you're cleaning up the work you've already been paid for. And if you haven't got a good maintenance contract with whoever you're supplying the code to, that can obviously cost you money. And ultimately, it can put businesses out. If you're a commercial firm and you're shipping crap code all the time, sooner or later, you'll be too busy fixing bugs to bring money in, and your firm will go under. I've seen that happen. Right. Are you happy with what I've said about robustness then? You think that's a reasonable description of it? Anyone disagree? Nope. Camera's great for that, I tell you. It really is. Okay. So how many of you do any of this in your own code? Do any of you have any techniques that you use today to make your applications robust? Anybody at all?
Validating forms. And
Validating forms, okay, yep. Okay, so that's input validation.
Your happy path's got a lot of steps in it.
Yep.
Fewer steps.
Fewer steps. That is a very good point. I haven't got a slide on that, but there may be one by the time the video goes up. I might steal that idea. But that is a very good point. the code that you can delete is code that can't go wrong. It's a very good point.
Just using the object hints wherever you can and all methods to stop it. At least on exception of the wrong object type for passed in.
Okay, I have a slide on that. You may not like it.
And then just wee checks inside it, you know, like get validation checks.
Okay.
Stop it.
Right. So part of what you're talking about there is taking advantage of PHP's type hinting and strict types.
Yeah.
So we're going to come back to that topic later on. I may have a different opinion to the majority of the PHP community. We'll get onto that. Anybody else?
So testing bad inputs.
Testing bad inputs. That's a very good point. I deliberately haven't covered testing here because in 3 weeks' time I'm down the road in Glasgow talking about code coverage, 100% code coverage and achieving that and the importance of it. So I deliberately haven't covered unit testing tonight, other than to say your happy path can have 100% code coverage and still have no robustness whatsoever. So yeah, if you can, come to Glasgow. I'll go through that. So I'm going to share with you 5 patterns that I use. So I use these in production code. Some of these I've been using since 1994. One of them I've only introduced this year. I'm still learning the full power of it and the consequences of it, because everything you do has consequences. But they have been very successful for me, and they've been successful for people I have taught, these 2. There are other solutions that may be as good, may suit you better. They may be better full stop. But these are the ones I use, and I'll explain why as well. The other thing is, this isn't an a la carte menu. This isn't a case of pick the ones you like and to hell with the rest. My experience is you need all 5 of these working together to really get robustness in your application. Any of these are missing, the fact that they're missing and haven't been tackled creates a weakness in your code. That's my own experience. But I'll explain those pitfalls as we go through. Now, this is as much for anyone who watches the video afterwards as anything. You'll notice the examples I'm going to use are very simple. There's very small methods. Some of them only got 2 or 3 lines in them. Now, that's deliberate. The reason for that, robustness isn't this huge thing you do. It's not turning monoliths into a huge nest of microservices and anything like that. It's something you do at the function level, at the method level. You do it a lot of times, but you do it in small chunks everywhere. That's why these things work. So that's why they're small examples. So let's move on to the first pattern then.